I am Dr. Sathya, working as an assistant professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss one nice topic, analytical techniques and electromaterials. This is the fifth unit of in our chemistry subject. So we are discussed what are the analytic techniques for using for determination of the material and what are the electronic materials we are used here. So, first of all, what is meant by the spectroscopy? So, the spectroscopy is the study some electromagnetic radiation. It's a interact with the matter. So, the electromagnetic radiation interact with the matter. This is the spectroscopy. So, the scientist can be the reveal some detailed about the molecular and atomic structures. So, in this diagram, one light will be affected to the prism and to form the different colored spectrum, that means a WebGR. So the powerful analytical methods, it's a root in Isaac Newton groundbreaking experiments with this prism, where the first demonstrated that the white light could be to give a rainbow of the colors. So why we need to study the spectroscopy? What is the importance of the spectroscopy? So to understand how the structure will be identified from this every structure. That means I need to understand the structure of matter and identifying unknown substance and ensure the safety and quality chemicals and monitoring the reactions and materials. Here the spectroscopy, we are going to see the introduction and what are the principles to involving the spectroscopy and the different types of spectroscopy is available. For example, atomic absorption spectroscopy, IR spectroscopy and UV visible spectroscopy and different types of spectroscopies is here, and also the applications. Why we need to study the IR and UV and atomic AAS spectroscopy? What are the applications? We will discuss now. So the basic principle of spectroscopy, the light source will be affected into the collimator, that's called the prism, and finally the wavelength selection. The particular wavelength will be selected and passed through the sample solution. Finally the detector will be detect the particular wavelength of the solution. So this is a electromagnetic spectrum. This is a fundamental technique for the spectroscopy. We already know about, we discussed a lot of things before the slides for electromagnetic spectrum. This is a different frequency here. The first wave is the radio waves, after that the microwaves and infrared waves, UV visible. In infrared and UV visible, in between we have the WebGR and then X-rays. Finally it will be a gamma rays. So it's been arranged by the frequency order. So how spectroscopic works? So the first step, irradiate. Shine some light or white light or electromagnetic radiation on the sample. It will be interact to the solution. That means the sample will be absorb the light and emit. One, emit or transmit or absorb. So the three things possible in the solutions. So the first, irradiate, and the second one is interact. That means interact with the sample. Finally the analyze the sample. So the shine light or electromagnetic radiation on the sample, it will be sample absorb or emit and scatter the some specific wavelength, and finally the resulting spectrum will be unique fingerprint of the material. So each substance will interact with the radiation in a different way to creating the signature pattern that the scientists to identify the characteristic unknown materials with the remarkable precision. So the different types of spectroscopic techniques is here. The one is the absorption spectroscopy, the second one is emission, third one is scattering. So what is meant by absorption spectroscopy? Measures the specific wavelength of light will be observed by the sample as the radiation passed through it. The emission means some light will be emitted when the excited atoms of molecule return to the lower energy state. That means the light will be enter into the solution, the light will be emitted from ground state to excited state. The molecular will be the excited atoms and molecule return to the lower energy state. So this is the emission spectroscopy. And finally the scattering spectroscopy. That means the analyze the light scattered by the sample. So the passing through the light to the sample will be the scattered the light. to understand the molecular interaction and structure. That means the molecule, how much of light will be scattered at a particular wavelength. So absorption versus emission. So what is mean by absorption? What is the emission? So the absorption means molecule absorbs the light. That means when electrons is jump into the excited state. From the ground state, the electrons are going to the excited state. This is the absorption. In emission state, the molecule emits the energy returning to the ground state. That means the light, the sample will be absorb the light to the electrons move to the excited state. If emission spectrum, the molecule will be excited from the excited state it to go into the ground state. So this is the difference between emission and absorption spectrum. So this is a diagram for emission spectra and absorption spectra. So this is the key spectroscopic techniques and their insights. So the different types of spectroscopic available: UV spectroscopy, IR spectroscopy, NMR and atomic absorption spectroscopy. So the real world applications, the spectroscopy is used in some medical diagnosis and astronomical and environmental production, and also in pharmacy, cosmetics, food. So in different ways the spectroscopic will be applied. So this is a spectroscopy to study how the radiation interacts with the matter and understand the structure and identify the substance, ensure the safety. And we have discussed the different types of spectroscopic techniques, the absorption, emission and also the scattering spectroscopy, and also the fundamental technique, how the spectroscopic will be works and the basic principle, and also the applications where the spectroscopic will be applied in medicine, astronomy and environmental.